Okay, John Marsh here, and in this short video I'm going to do problem 4 from homework 2. Problem 4 from homework 2 states that the snap header in the Ethernet framing, explain the use of it and draw a later diagram showing how the snap layer sits relative to the PHY, MAC, LLC, and transport layers. See topic 1 slide 24 for some idea of the diagram. Okay, so let's go to topic 1, slide 24 here. And basically this is the slide which shows how the link layer, that is layer 2, is divided up into two pieces, the LLC and the MAC. Logical link connection and medium access control. Okay, and the question is, when we use the snap header, where does that fit? Well, where's my snap slide here? Okay, here's the snap header slide, basically. In topic 1, slide 26, is showing that, well, what it shows here, the previous slide shows that in the original, I guess it's called a DICS format for the Ethernet header, we have 2 bytes which tell the type of payload which is in here. And in here we have payload from a higher layer, which would be layer 3 in this case. Okay. And then when 802, when the IEEE 802.3 came out, those 2 bytes were used for the length, giving the length of the data in the pad. Okay. And you need to know that because as the frame is being processed, you need to know how far to read before the frame check sequence starts. Okay, so you need to know that. So IEEE considered the length to be the most important, but then they revised it finally, and now we have either the length or the type encoded in these 2 bytes. Okay, and that gives flexibility so that we might be able to tell what type of payload is in here. And this might be important to know whether it's, for example, an IP or an AppleTalk or whatever other type of layer 3 information you need to have about the higher layer in there. It turns out that we really need both a lot of times. Both length and type of the layer 3 payload we'll need to have. And that's where the SNAP comes in. It's called the Subnetwork Access Protocol. And basically what you do, if you can read this, we've got our 802.3 header here. Okay, and in the 802.3 we're going to use those 2 bytes for the length. Okay, and we know that inside the payload of 802.3 is the higher layers. Well, the MAC layer is actually, that is the Ethernet layer we're considering, the MAC layer we're considering is actually the lowest of these 2. And so inside the MAC frame we're going to have the LLC frame. And then we're going to have the network layer. Okay? But then you can see, okay, so you can see the 802.3 header here. Then we've got our LLC header. And then the snap is fitting right in between the LLC and layer 3. Okay? And so this gives us the hint that what we're going to do is we're going to have layer 4, layer 3, layer 2, and then the physical layer in our generic sort of, easiest layer diagram like that. And then we're going to divide layer 2 into the LLC and the MAC. And then finally, from this picture you can see that the snap is in between the LLC and layer 3. And so what we really have now is the following. We have the physical layer here. We have layer 2, which consists of the MAC layer. That's Ethernet. The LLC, and finally the snap. And layer 3, IP, and layer 4 TCP. And I think that answers the question. Yeah, there's the transport layer of the layer 4. Okay, so that's how the snap fits in, and you can tell where it sits simply by looking at the position of that header relative to the others. Okay, hope that helps.